Hello dear students, so now today we would move ahead in this first chapter of class 12th chemistry, that is solid state. Okay, so now here we would be discussing some other terms related to the cell, okay, related to the unit cell. Okay, so the first one is the edge length. So what is edge length? Edge means this one. So this is the edge. How many edges are here? If you see, there are 12 edges. Okay, one is 2 3 4 5. This is how these all are the edges. Okay, now if you are to find out edge length, so edge length is what? The distance, the total distance of an edge. Let's say this is the edge here. Okay, so this total distance means from here to here. So this total distance would be known as the edge, isn't it? Okay, so edge length means the total distance of an edge, the complete distance of an edge from here to here. This total distance is known as edge from here to here. Getting it? So I will be writing here total length of an edge is known as edge length. Okay, now if you are to find out nearest neighboring or nearest neighbor or nearest neighboring distance. Okay, so the next term that we are going to talk here is the number 2 is the nearest, right there, nearest neighbor, or we can say it as the nearest neighboring distance. So we would represent it by D. Okay, so nearest. Now if you see over the edge, you have the particles at different places. You would have the particles here also. Okay, the particle can be here also, isn't it? Getting it or not? The particles can be here also, the particles can be here at the corners also. Okay, means over the edge you would see the particles can be anywhere. Okay, so now nearest neighbor means the distance between two nearest particles or atoms. Okay, so let's say these are the two nearest atoms here. So this one distance means from here to here. So this one distance would be known as the nearest neighboring distance. Okay, nearest neighboring distance. Okay, so nearest neighboring distance means the distance between the two nearest atoms or particles. Okay, so right here the distance between two nearest atoms and particles is known as the nearest neighboring distance. Okay, now suppose you are to find out the radius. Okay, the radius. So what is radius? We would denote this by the letter R. Okay, so now what is the radius? So radius, if you see, means this is the distance between two nearest nucleus, you can say. Okay, are you getting it? Two internuclear. So this is the internuclear distance, means the distance between the nuclear the internuclear distance we would be just calling it as the radius. So radius is the internuclear distance. So I would write here the internuclear distance is known as the radius. Okay, and we would write it as R is equals to D by 2. So it is what? It is half of the distance between the two nearest atoms. Okay, half of the distance between the two nearest atoms. So this is known as the radius, or we can call it as the internuclear distance, isn't it? So we would call it as the radius. Are you getting these three terms? Okay, now in the examinations you would be getting the questions on the basis of all these three. Okay, so now let me first define the relation here. Okay, so I would be defining the relation. So let me write it here, relation. Okay, so I will be defining the relation between D and A. Okay, and then I would be defining the relation between R and A. Okay, now what is the relation between D means the nearest neighboring distance and the edge length, and what is the relation between radius and the edge length in case of simple unit cells, then body centered cubic unit cells, then you have the face centered cubic. These three types of unit cells I'm taking. So first one is let's say it is which one? Simple unit cell. or you can say the primitive one. Okay, simple unit cell. Then in the next case we have the body centered cubical unit cell. Then we have the face centered cubical unit cell. Now you have to find out the relation between D and A in case of the simple unit cell. Okay, so what is the relation between D and A in case of the simple unit cell? So if you are direct, you can write the formula there. In case of the simple unit cell, so D would always be equals to A. Means the nearest neighboring distance would always be equals to the edge length. Okay, in case of the simple unit cell, because in simple unit cell you have the particles at the corner. So one particle would be here and one particle would be here. So these are the two nearest particles. So that is how we can say that the nearest neighboring distance is always equals to the edge length in case of the simple cell. Okay, simple cubical unit cell. Okay, now if you have the body centered cubical unit cell, then for that there is a relation, and the relation is D is equals to, right here direct, D is equal to 0.866 into A. 0.866 into A. Okay, now if it is face centered cubical unit cell, then you have the relation between D and A as D is equals to, you can write as 0.707 A. Okay, this is the relation. Okay, now we would find out the relation between R and A in case of the simple unit cell. Now if you see the relation, so in case of simple unit cell, the relation is R is equals to A by 2, because R is actually D by 2. Getting it or not? But in case of simple unit cell, D is A, so I can write R is equals to A by 2. Similarly, you have to find out the relation of between R and A in case of the body centered unit cell. Getting it or not? So now for we have R is equal to D by 2, so in place of D you would put this one value, 0.866 into A. So put this value here, just divide it by 2, you would be getting the value of R, isn't it? So you would be getting it as 0.433 A. So you have R is equal to 0.433 A. Okay, now similarly you would find out the relation between R and A in case of the face centered cubical unit cell. So it would be R is equal, so R is equal to D by 2. So D is how much here? 0.707A. So put it here, divide it by 2. So you would be getting 0.3535A. 0.3535A. Okay, so this is how you would get the relation between the DA and R and A in case of simple body centered and face centered cubical unit cells. Okay, now on the basis of this you would be getting the questions in the exam. Okay, so let's solve some questions also. Okay, let's say you have a body centered unit cell. Okay, before this let me erase this all. This one I am not gonna erase, okay, because you would be taking the help of this. So let me erase this all if you have noted it down. Okay, now if you see, let's say you have a body centered cubical unit cell. Write down a question. There is a body centered cubical unit cell. Okay, there is a body centered cubical unit cell, and for this one cell we have been given the edge length, that is A, and this had been given as 200 picometer. Okay, and you have to find out D and you have to find out R. What would be D and what would be R? Okay, so now you have the cell, that is body centered cubical unit cell. So for body centered cubical unit cell you have D is equals to how much? 0.866 into A, and value of A you have been given. So you can write D is equals to 0.866 into A. So D would be equals to 0.866 into A is how much? A is 200. Just multiply these two, you would be getting the value of D in picometers. Okay, now similarly you can find out the value of R also. So if you want to find out the value of R, so you'll be knowing R is how much? In case of the body center it is 0.433A. So write it 0.433A. So just put the value of A there. How much it is? 200. So put it here. So you'll be getting the value of R also. Okay, just multiply it, you would be getting the value of R in picometers. Okay, so this is how you would solve the numericals also. Okay, one example just I have given to you. Okay, few more we will be discussing in the upcoming lectures. Till then, stay tuned and keep watching. Thank you. Have a good day.